All right, next question up. And what we see in this pretty lengthy problem here is that the first thing we need to do, as always, start with the question sentence. Now, sometimes the question might begin with the word if, and really all that means is they're beginning with some conditional information. So, if the drain can yada, 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 I don't care, this is what I care about. How many hours will it take to completely drain the pool? Everybody, what are we looking for here? What kind of a unit are we looking for when they ask, how many hours will it take for anything to happen? Yeah, we're looking for time. We are looking for time 100%. So that's what I'll begin with. I'll begin right over here and say, let me highlight it. How many hours? Right there. How many hours? That is time. So we are looking for the time it'll take to drain the pool. To drain the pool. All right, sounds good. So let's see if we can make any sort of sense here at all. Because at first, though, I think we can all agree before we, get past this point, I think we can all agree that, yeah, how many hours does mean time. And they do very explicitly say the time it takes to completely drain the pool. So even if we don't know how we're going to get there, I think we can agree that we know what we're looking for. So that's a good step forward. Now up next, let's see how we can actually make sense of the process of how we're actually going to calculate that time. So if we take a look, let's begin at the top. The top says a swimming pool is 8 feet long, 20 feet wide, and has a depth of 5 feet. If the drain can remove water at a rate of 50 cubic feet per hour, how many hours will it take? Okay, so here's what we're actually talking about, everybody. We're talking about a pool, and so let's just go ahead and draw this up just like that. And then I'll go ahead and just duplicate this over there. And let's give the illusion over here. Let's give the illusion that I can actually draw. And then we have our depth. If we're looking underground, this is the depth of our pool. Just like that. So we have this pool because, this is the surface here and we have the water right there. And so there's a lot of water all here, okay? So we have this pool and we were told that we have its length, it has a width, and it has a depth. Everybody, what does it sound like we're talking about when we're talking about draining the pool at a rate of, don't worry about the 50, but take a look at what's next to it. Cubic feet per hour. Everybody, what are we discussing there? Cubic feet, what does that discuss? Volume. All day. Remember, everybody, cubic means three-dimensional. Volume is a three-dimensional unit. So I can tell you right now with a high degree of confidence that 50 cubic feet per hour is how much volume we're removing per hour. Everyone, does that make any sort of sense at all when I say that? When I say, hey, look, cubic feet is volume. And so if we're removing 50 cubic feet per hour, that means that that's how much volume we're taking out every hour. Now, when I couple that with having the length, width, and height, which is the depth in this case, everybody, can we calculate the volume of the pool? Can we calculate that with the information we have? Absolutely. Yeah. Everybody, this is a rectangular prism. This is a pool, but it is a rectangular prism because we have those 3 dimensions there that we just discussed. I can move this over here to the top. We can begin calculating the volume, but I'll show you how that's not going to be enough. Take a look. We have length, width, height. We have 8 times 20 times 5. Everybody, let's do the 20 times 5 first because that'll be the easiest one. 20 times 5 is what? Pop quiz of the day. Yeah, hardest math of the day, that will be 100. 20 times 5, right there. And then everybody, what's 8 times 100? What's that going to be? 800. Sounds good. So the volume that we're dealing with in this pool is 800 cubic feet. The amount of water that we're draining is 50 cubic feet per hour. So here's where this is going to go now, everybody. If every hour we can remove this much water, this much water, this much water, what operation do we need to do to figure out how many times we can fit 50 cubic feet into the pool? I love it. You guys are naturals. Division. Yes. One more time. Let me just say it one more time because I want to make sure we understand it. If we're trying to see how many times we can fit or take out 50 from the pool, how many times we can take out 50 cubic feet, that's division. Again, division is the opposite of multiplication. Multiplication is this times that. Division is how many times can we do that? And that's exactly what this is. How many times do we take 50 cubic feet out until we're done? And that'll give you the number of hours. So let's go ahead and finish this up here. Let me move this up to the side, right over there. And we're going to divide the 800 cubic feet by the 50 cubic feet per hour. That's going to give us our answer. And we'll go ahead and calculate this first by just giving ourselves a little bit of wiggle room. Let me just remove that final 0 at the end there to make this 80 divided by 5 much easier. So now we'll do 5 going into 80. 5 goes into 8 just once. Subtract the 5 to get 3. Drop that 0 down. 5 goes into 30, everybody. How many times? Yeah, that'll be 6. So there we go. 16 hours. That's how long it'll take to completely drain the pool. From full down to empty. The correct answer here, my party people, is answer choice C. 16 hours.